Alright, there seems to be a little confusion about what you're supposed to be doing in this introduction to HMI. And I've got a video there, and I just wanted to kind of rehash it one more time here. So, an HMI is a device that we use So an HMI is a touch screen device, like you see in the very upper left-hand corner of this screen that I'm showing you now, that allows us to create virtual buttons and images of things that may be happening with whatever process we're interfacing with the PLC. So let's forget about the HMI for a minute. Obviously over here with the person's hands is a little package controller, MicroLogix. And down here is a little conveyor system. And this is actually the conveyor system that's here in Dublin that you're writing me a program for. So your task, until we introduce the HMI, is pretty much what you've been doing up to this point, is you'll see there's two buttons, a green button and a red button. And those are momentary switches, so you push them and let go, so they close when you push them. Or actually, the green button closes when you push it. The red button opens when you push it. So this is a normally open switch. This is a normally closed switch. And when you press this button and turn on bits 4 and 5, this conveyor goes forward. So I'm asking you to write me a program that does that using your simulator and just using lights to represent the conveyor. So your program should match what you see in the lessons here, which is not that. Get back to my Word document. Sorry about that. Here it is, PLC project map. So you're to write me a program using the simulator that when you press start, the conveyor comes on, turning on bits 4 and 5, and it stays on because it's got a latch, because obviously when we let go of that button, these need to stay on. And if we press stop, it'll stop them. Anytime the conveyor is running, I need the green lamp on, and anytime the conveyor is not running, I need the red lamp. So that's just writing a simple program. It's writing press start, turn on outputs 4 and 5, keep them latched even when we let go at start, unlatch it when we press stop. Normally open switch, normally closed switch, and you can use bits 4 and 5 for your conveyor, and you can use bits 0 and 1 for your red lamp, and in fact those mirror the addressing on the conveyor, with the difference being the slot numbers. So that's easy, in my opinion, and especially if being in the advanced class at this point, that should be really easy for you. So the very first step is to write that program, and if it'll work on your simulator, that it's going to work in my real world. I'll take the program you send me, I'll validate it, and I'll put it in the PLC out there with a little bit of address changing to adjust for the difference between the addresses on the simulator and the addressing on the actual device. Now, where the modification comes in is the HMI. The HMI is a virtual device that it keeps us from having to put in hard switches and hard indicators, and they can mirror at least the outputs of a process. So what you need to do with the Seymour software is write and create a program that has basically this right here mirrored. I need a start button and I need a stop. That start button needs to be normally open. That stop button needs to be normally closed, and these lamps are just lamps. So these buttons need to be their own address. They're not going to duplicate the address here. It's going to be as if we installed a second set of buttons. The only difference is these are virtual buttons, not real world I/O. And because they're virtual buttons, we have to give them the address of a storage bit inside of the PLC, which is a B3 address. And if you'll watch the other video, you'll get that. So what you'll be doing is creating this little box right here that has the 2 buttons and the 2 lamps. Now the lamps will share the same output addresses. So basically, if the green lamp's on, the green output here will be on, and it's going to be looking at that data table bit for the green lamp or the red lamp, depending on which one. So all it's going to do is say, hey, is this output on? Yep, then I'm going to turn on this virtual lamp on the screen. But these buttons, because they're independent buttons, have to have their own address. Those will use storage bits, and they will be in parallel with what you see here. So you'll need to send me your program, not a screenshot, not a picture, not where you installed it. You'll need to send me a Seymour program that does that. Now, if you've got access to the Dublin campus, I would encourage you to come here. It'll be much easier to do here, but if not, I'll try to work with you. But we're only talking about 2 inputs and 2 outputs being developed on the Seymour. The outputs addresses will mirror, or tags will mirror, the outputs on the PLC. The inputs will be storage bits. So once you write that Seymour program, then you've got to go back and modify your PLC program. Now, the only thing you added that had a different address will be your buttons, your start and stop buttons. And this is not one that works. This is just a screenshot of the Seymour software. So inside of your PLC, you'll need to have those storage bits be in OR with your actual button. So whether I press this real button or whether I press this virtual button, my conveyor is going to come on and latch. Whether I press this real stop, whether I press this virtual stop, my conveyor is going to stop. And that's pretty much it. So it's not that hard. I know it's kind of confusing because you're not seeing this equipment, but these little devices are very inexpensive, relatively speaking. This guy we've got is about $300, and I know, well, that sounds like a lot, but we're only touching the tip of an iceberg. If this were an entire process, I could draw everything that's on this conveyor. You could see cylinders as they fired and moved the disc. You could see all the lamps, all the lights, all the sensors. So it can do a lot more than just what we're doing, but what we're doing gives you the essence of what we can do with an HMI. So just to give you some feedback there's 3 forms of communication. We first have to have a computer to write this Seymour program with. Have to have a computer to write the PLC program, and then we have to interface our Seymour screen with our PLC, and that can be done either through the internet or through a hard cable. So you would first hook a computer to your PLC, write the program, verify your program by hooking it to running it on the conveyor, then write your Seymour, integrate the Seymour bits into your program in the PLC, and then connect your Seymour device to the conveyor. And that's it. So not a real hard task. It is a little bulky and explaining, but that is what I need you to do, and that's your task. And again, if you have access to the Dublin campus, I can promise you this will be much, much easier touching and feeling the software here. If not, get with me. I'll be glad to help you. I've got to see you accomplish this task, but I'll be glad to try to explain and get a little more in depth. But it's really not as hard as it might seem at first glance. So it's kind of like, I don't know how many of you have any devices that you control with Alexa. And I have an Alexa device here in my office, but you can buy little things that let you turn stuff on and off just by telling that device to turn it on and off. Well, you can still turn it off at its normal point too. So if I had a lamp that has a switch on it. I can turn it on and off with that switch, but also I can ask my device to turn it on and off. So it's just a different way to accomplish the same task. And like I say, HMIs are way more capable than what we're using them for here, but I'm not asking you to draw and integrate this entire process. I could, but I'm just trying to keep it simple and trying to get you to understand some of the capability of an HMI. And that's where we're at. So if you have questions, please let me know.